game is played by a cat and a mouse named cat and mouse. The environment is represented by a grid of size rows into columns where each element is a wall, floor, player, or food. The players are represented by the character CNN, floor, dot, walls has food F. Okay, there is only one cat and one mouse and one location where food is located in the grid. Mouse and cat play according to the following rules. Mouse moves first. Okay, then they take the turns to move. During each turn, cat and mouse can jump in one of the four directions. Left, right, okay. They cannot jump over the wall nor outside of the grid. Got it? Now cat jump, mouse jump are the maximum lengths. Cat and mouse can jump at a time respectively. Cat and mouse can jump less than the maximum length. Staying in the same position is allowed. Mouse can jump over the cat. The game can end in 4 ways. Okay, mouse can jump over the cat. But can cat jump? Okay, the game can end in 4. Okay, that's why cat cannot jump, because if cat occupies the same, okay, cat can eat the mouse. Cat eats the food, then cat wins. Mouse eats the food, then mouse wins. And if mouse cannot get to the food within 1000 turns, cat wins. Given a matrix grid and 2 integer, cat jump and mouse jump. Maximum length, cat and mouse can jump at a time. Cat and mouse can jump less than the maximum length. Return true if mouse can win the game if both cat and mouse play optimally. Otherwise return false. Got it? Environment is represented by grid. So we have a grid where there is a cat, there is a mouse, and there is one location where there is food and some walls and floor. Now who is moving first? Mouse can win the game if both can return true. Cat and mouse can jump. Mouse moves first, then they take turns to move. Cat and mouse can jump one of the 4 directions. Okay, I can write recurrence relation for this easily. Let's try. So can mouse win? Can mouse win? So can mouse win? We have to return true if mouse can win, right? If mouse can win the game, if both are playing optimally, we have to check whether mouse can win the game or not. Okay. So how if I let's say this solve function, bool solve some parameters, it represents whether mouse can win the game or not. This represents, so that means it should be solve only. I just need to return solve means whether mouse can win. Where does it? So if mouse is at some location, cat is at some location, how to find the DP state? Is it DP or no recursion state? Maybe recurrence relation, how to form? So if I'm at here, it is mouse and it is, so it can go in all the 4 directions in a move. So how to find the solve? What is required? So where is my mouse? that location, where is the x location, where is the y location of mouse. Represent this x location of mouse, y location of mouse. And similarly cat, x location of cat, y location of cat. And whose turn is this? 0 means mouse is playing, 1 means cat is playing. Okay, it is cat's turn or mouse's turn. What else? So if mouse is standing at xy, xm ym, cat is standing at xc yc, and its turn, it's mouse's turn, then how can the mouse move? Let's make, so it returns me whether mouse can win or not. Do I need anything else? So the cat occupies the same, okay, staying in the same position is allowed. Mouse can jump over the cat, so mouse cannot get the food. And okay, how many steps we can say, how many steps so far mouse has taken? Is it all or anything else? Let's see. So I can say if it is a mouse's turn, what it will try to do, it will try to, okay, we also have this thing, it can move at max this length, right? Cat jump or mouse jump, the maximum length. I think these two will remain constant. The jump of mouse and jump of cat. Right, I think this is all I need so far. So if mouse is at my xm ym, let's see, so it can stay in same position, that means it cannot move 0, it can move 1 in the right, it can either move 2 points in the right. So these are the x locations, and similarly y. So initially it is 0, that means it is only moving in the 0, it is only moving in the x direction. So it can also move 3 till jump of, what is the maximum jump mouse can take. Okay, but if it is a, okay, it can only jump if it is floor. If there is a wall and then again floor, can it jump to this? No. If there is a wall, can it jump beyond that? If there is a wall, can it move beyond that? I think once I get to a wall, I should not be able to jump on that wall, right? Yeah, so once I get to a wall, so this is floor, this is floor, this is floor, and this is the wall. So till I can jump till the floor, but if I get a wall, even if there is a floor, I should not be able to jump it, right? Because mouse can only jump over the floor. And mouse, the mouse, they cannot jump over the wall or outside the grid. That means, but how to go till this direction? So if I have if I'm standing at x and y, let's say if I'm standing at x and y, and I want to dx dy of jump to get to the new location x1 y1, can I say if I can jump till j, right? If 0 and 1, if let's say 1 1, can I make a jump? It can move in all the 4 directions. So here, suppose mouse jumps in this direction, it starts jumping in the direction, what is x is 1, y is 0, right? So I can just multiply it by jump jm to get to the maximum one, right? One will be multiplied by jm. I think I should be able to write. Let's try. This should be the recurrence relation. How to write? So I would need the mouse location, x y of mouse, x of cat, y of cat, the cat's y location, and what else? xm ym xc yc. Whose turn is this? Whose turn is this? And how many steps mouse has taken so far? Mouse steps. And what is the max jump of cat and max jump of mouse? Okay, so if it is mouse's turn, it is the cat's turn. If turn is 1, that means, let's see what will be my answer. What is the starting location of mouse? I don't know, so let's say xm ym xc, cat's x location yc. Okay, go to the grid. Grid dot size. Less than grid of 0 dot size. So if it is, what is cat? It is c. So if grid of iz is equal to c, you can say xc is equal to I and yc is equal to j. This, if grid of iz is equal to, it is mouse's location, then I think I would need the food's location also. Where is the food? Because anyone who reaches the food, that will be the base case, they win the game. Do I need the food's location, or I can directly derive from the first? Yeah, I can directly derive. So I grid size, j grid 0 size. If it is cat xci yz, then x of mouse is I and y of mouse is j. After this, xc, let's start with the mouse, xm ym xc yc. Whose turn is this? Let's say 0 means mouse turn. And how many steps mouse has taken so far? It is 0. And what is the cat jump? What is the mouse jump? Okay, it is cat jump. Let's see, cat jump and mouse jump. This will be my answer. So if it is 0, that means this is the mouse. That means this is the mouse. Whose turn is this? Now let's move the mouse, how it can move. So from this location it wants to move, so I can go, let's define our dx dy into dx of 4 is 1 minus 1 0 0, and into dy 4 is 0 0 minus 1 1. So if I am at xm where can I go? Xm plus dx of I. It's okay. Let's try to go in all the four directions and k is equal to 0, k less than 4, k plus plus. So I can take in this direction. I can take how much jump. Let's go and take the jumps. And jump length is okay. 0 means I can stay at the same location, right? I don't take a jump. And what is the maximum jump? So let's say mouse jump and jump plus plus. So xm plus dx of k into jump. Yeah, so this is the new x1. Similarly, what is the new y is y of m plus dy of k into jump, right? Y of m x of m plus dx of k into jump, dy of k into jump, x1 y1, the new location. Can I go to this new location? I can define a function can go to this location inside the grid. It should be a character array. Can I go to this location xy inside this grid? So it is a bool. Okay, say return x is greater than equal to 0 and x is less than grid dot size, and y is greater than equal to 0 and y is less than grid of 0 dot size, and it is not a wall. So grid of xy is not equal to what is wall? Wall is hash, is not equal to this. Can I go? It is inside the grid. Y greater than equal to y less than grid 0 size, and grid of xy is not equal to hash. Okay, if can go to x1 y1 inside the grid, would need the grid also. What is this grid? For k equal to 0, for jump is equal to 0, it is the max jump. Okay, it should be equal to this. It is the max jump. I take the jump, go to x1 y1. If can go to x1 y1, if I cannot go to x1 y1, should I break? Or yeah, I should break, because if I cannot go to x1 y1, that means it might be a wall, or I'm already outside the grid. So if it is not if I cannot go to this location, that means it should be a wall, or I'm at the end. So if I'm at the end, that means break. Okay, fine. If I'm at the wall, if I don't break, that means in the next value of jump, let's say jump is 3, So if I don't break, it will also calculate jump is equal to 4. That means I am jumping over the wall. But I don't want to jump over the wall. That means I should break even if there are floors after the wall. That means it should break here if I cannot go to x, if I cannot go to x1 y1. Okay, else break. Fine. Now if mouse can reach to x1 y1, then can it win? Then I need to solve it for, let's see, solve for what is the mouse's new location. It will be x1 y1. Cat's location will remain same, xc yc. Mouse steps will increase by 1. Cat jump and mouse jump are, I can extract them in global variables, but fine. What is the maximum jump cat can take, what is the maximum jump mouse can take, and what is the grid value. Okay, so this will give me, if it is the cat, this function, if this is the mouse's turn and it takes a jump of this value, jump value, and it goes to x1 y1, so from there, so if mouse can win, then only it should take the jump, right? So if mouse cannot win, so if mouse goes to this location and from here again it wins, from here it wins, that means it is a good location. But from here, from x1 y1, if it loses, that means cat wins, then it should try other location also, right? Yeah, so it should see if solve, if it is true, that means I should return true, but if it is false, I should not return, I should try other locations also. And finally, after trying all the all the jumps and all the location, all the directions, if it cannot move, that means what should be the value? That means mouse cannot win from this location, right? From this location mouse cannot win. I can say कि if this happens, I can return true, that mouse can win. But if it does not happen, then I should try other possibilities also. And finally, after trying everything, I should say कि can mouse win? False. And here I can return can mouse win. No need to write this here, you can initialize it also. Okay, let's see. If turn is 0, that means mouse cannot win. If turn is 0, that means it is mouse's turn, then it can go to all the 4 directions, take the jump, and from the new location, if it can win, it can go to the new location, and from there it can win. That means the current location is a winning location. The current location is a winning location using this set of steps. That means I can return true directly if I find any of the good location x1 y1. But if I don't find anything, that means it will remain false. It will return true from here directly, so it will not be executed. Fine. Now if it is a cat's location, what will happen? I think cat will also try something like this, but it should be similar. Let's see what changes do I need to do. So cat, it should be cat jump. So cat jump, so it tries to go to all direction, take a jump till at max cat jump, go to new location. If it can go to this location, fine. Now mouse can jump over the cat. So if cat goes to if it can go to this location, then fine. Can cat jump over the wall or not? They cannot jump over the wall nor outside the grid. If cat can jump over the wall, then we should not write this break, right? Yeah, otherwise what it will try, it will go from here. Solve true means mouse can win. So what should cat do? If cat is at this location, if it goes to x1 y1, and from x1 y1 if mouse wins, then should cat take that path? No. If mouse cannot win, then only cat take the path. So if mouse cannot win, so from here, okay, this should be xm, because mouse is not moving. Xm ym, this should be x1 y1. Xm ym, x1 y1. And okay, I forgot to mention whose turn is this. So if it was 0, that means mouse turn, 1 means cat's turn. And how many steps it has taken? Cat jump, mouse jump, and grid. Similarly, it should be mouse jump, x1 y1. So cat is here, x1 y1, and the next turn is mouse turn. Mouse step is not increased. Cat jump, mouse jump, grid. So from here this function returns false, means mouse cannot jump, means cat can jump. If cat can jump, that means this function should return false. This function should return false, means from this position mouse cannot jump. If it is cat's turn, it tries and goes to x1 y1, and from x1 y1, that means in this state mouse cannot win, then cat should directly return false, because but if mouse wins from this location, if it returns true, mouse wins. Should cat take that step? No, it should try other step also, right? If it tries other step, and in that step mouse cannot win, solve if solve is true, that means it will try next thing. If again solve is true, that means mouse is winning. It tries next step, it keeps on trying the next step until solve becomes false. So once solve becomes false, that means cat wins. Okay, is the straight true? Yep. Now the base cases, and what will happen here in this case? If it is never executed, what will happen? I think this should be marked as true. Can mouse should become true by default, right? So can mouse win true. So if from all the possible states mouse is never able to win, no, cat is never able to win, that means this is never executed. In that case, can mouse win should become true, and here I should return true. And in this case, if mouse should go to that state where it again wins, right? Then it becomes true. But if it becomes false, that means it should try other step. So return true. That means if it is never returned true, that means by default it is false. That means cat is winning, so it should be false. Okay, let's see what are the base cases. How to write the base case? Hmm. Let's see. If mouse steps is first base case is if mouse steps exceeds 1000, return cat wins. Cat wins means 1. No, cat wins means 0. That means mouse loses. Mouse loses means 0. Hmm. And if it is cat's turn, if it is cat's turn, and so how to find these things? Game can start in 4 ways. If cat occupies the same position as mouse, then cat wins. So from my function, if it is a cat's turn, so cat goes to that location. If cat can go to x1 y1, that means here, that means x1 y1, this at this position mouse should be present, right? At that point mouse should be present. That means x1 y1 is equal to xm ym, and it is mouse's turn. That means who would have sent it here? It should have been the cat, right? Yeah. So if mouse steps is greater than 1000, that means mouse loses. And if the turn is 1, that means it is cat's turn. Right now it is cat's turn. And it is cat's turn. If it is cat's turn, and from here, so if it was mouse's turn, then it would have taken. So if it is cat's turn, that means previous one was the mouse turn, right? So if previous one was the mouse turn, then mouse must be at this location. Right now mouse should be at x1 y1, and cat must be at xyc. Cat must be at xyc. How to find the base case? Cat was how to find. Okay. So if does it depend on the turn? No. Let's try it this way. Okay, if xm ym, if mouse is standing at the food, then who is winning? Mouse is winning, right? Yeah. If the grid of xm ym is equal to food, that means this is winning. Similarly, if the grid value of cat's location yc is equal to food, that means cat is winning. It means return 0. It means mouse is losing. What could be other case? If cat and mouse are at the same location, that means, so if xc is equal to xm and yc is equal to ym, that means cat is winning, right? Yeah. Okay. Should it be 1000? Let's try. No name ym. xm ym xc yc. xm ym xc yc. Line number 24. xm ym xc yc yc. Okay, these are integers. What the? Okay. Okay, whose turn is this? How much steps can it take? What is the maximum cat jump? What is the maximum mouse jump? Okay, did not work. Let's see. Mouse can win is false. So if it is cat's turn, then can mouse win? I can mark it as 1. Go to all the 4 directions, make the jump till the cat jump, and find the new location. If it can go to the new location, x1 y1 grid, let's try to jump. Grid 0. So mouse's location remains same. It will be the cat's location which changes. And cat jump, mouse jump, and grid. So if it happens, if mouse cannot win, so it directly return false, or we can break. If we can break, then it will return true. I don't like this one, so we should be playing optimally, right? So if mouse cannot win, then cat should take that route, right? It means it should return false. Let's break, otherwise go here, k jump, take the mouse jump, x1 yn xm plus dx. Is this correct, or I think it is cat's location now, so it should be xc yc, right? Yeah, and it is mouse's location xm ym x1 y1 cats. Okay, time limit exceeds y. Can I try 100? Grid 0 size. Let's try the DP one. How to write the DP? So enter DP. The location, what is the max it can go? Is 8. Okay, so let's say 9. Again this is 9 and whose turn is this? So two values 0 and 1. How many steps it can take? Let's say max 100. It should be 99 because 8 into 8 64 maximum, so 67. But let's see 99. If 98, it does not matter. 98. And mouse steps, cat jump, mouse jump. This is the DP one. Let's initialize this DP. Mem set DP as -1, size of DP. Okay, we can say bool answer is equal to DP of this state xm, ym, xc, yc, turn and mouse steps. The DP, and if it is not -1, answer is not equal to -1, we can return answer. We can say answer is equal to, we can say answer, I think if we are returning here, answer is equal to true, answer is equal to false. Let's try now. Compilation error. Why bool answer? It is int answer now. It is integer. Yeah, working. Solved it a lot of times. Yeah, worked again. Great. I think it was 18 to 8, that's why we can stop it in 98 steps only, or 64 at max. But what was the crux of this problem? So it was, I think, the cat and mouse decision, because we are writing in terms of the mouse. Can mouse win? So if it is the cat, so it is the cat's turn. What it will try? It will try to choose that path from where the mouse cannot win. So if it goes to x1 y1 and from there mouse cannot win, that means it returns false. Then my function returns false. Then it directly returns. But if it returns true, that means mouse can win. The cat should again choose another path. But if after trying all the paths it cannot return false, then that means it would have to return true. That is the final case. Similarly for mouse will try to move to all the locations. Mouse will try to take all the paths, and if it can find at least one path where it can win, then it will directly return true. But after finding every path, if it cannot find a path which returns true, that means in that case it should be false. So that is here. In the base case, yeah, if mouse is at the food, mouse wins. Cat is at the food, cat wins. If cat and mouse are at the same location, that means cat eats the mouse, that means mouse loses, that means cat wins. Okay, I think this is a good backtracking question. Memoized with DP. but yeah, recursive question I am able to write. Let's try much harder question in recursion. Okay,